Okay, a very good morning to all of you. I think my voice is audible. Give the QR code, then we will start. Okay. Give the QR code attendance, then we will start. Yesterday's lecture, it was delayed to upload. So today I have uploaded the lecture. So just have a look, go through it. Okay, because we were discussing frequency synthesizer signal generator, and we discussed it half portion, right? Two methods are there, indirect and direct. So I think we have discussed only the indirect method of that. So today we will proceed towards direct method. Okay, so I think you all have given the attendance. We can start now. I'm sharing the PPT with you all. So we were discussing, I think my PPT is visible. So we were discussing the methods of frequency synthesis, these are the methods. Out of this, we were discussing indirect method mainly. So phase locked loop, and out of this method, what are the components we had? VCO, programmable divider, phase detector, phase reference, loop filter. Okay. So can you tell me anyone which device is used to eliminate the harmonics from the system? Out of these components, which device actually helps in removing the filter, removing the harmonics from the system? Can you tell me anyone? Please reply. Out of these components, means VCO, a programmable divider, phase detector, phase reference, loop filter. Out of these 5 components, which component is capable of removing the harmonics from the system? Give me the answer. Manorama, Josna, what is the answer? Yesterday, previous class, I have discussed now all these things with you all. So tell me the answer. Rashmi, Rani Rupam, hello. Are you there? Hello?
Yes, ma'am.
Yes, what is the answer? Aditya? Tell me the answer. Tanisha, Shalini? No response. Rajkumar?
Loop filter.
Yes, very good. Loop filter. So it seems that I only teach Rajkumar and I don't teach other students. It seems like that. No response. Even if you don't know the answer, when I'm asking your name, you could have unmute yourself and tell me, yes, ma'am, na? That is a bit courtesy, which is not expected from your. It may happen, you don't know the answer. It is acceptable. Everybody know the correct answer. I don't expect that. But at least when I'm asking your name, when I'm calling your name, you should have unmute yourself and tell, yes, ma'am, I'm not confident about the answer, but I don't know the answer. There are some things you should tell, na? This is a minimum courtesy you should have. You are growing, you are adult now. Okay, so some disadvantages are there for this indirect method. That is why we are shifting towards a direct synthesis method of this PLL. That means not PLL, it's frequency synthesizer signal generator. So what happened in direct synthesis? See here some frequency, some different values of reference frequency I've shown here. So in this method, whatever written in the slide, I'm just going through that first. In this method, a single 18 megahertz reference frequency. So keep in your mind the reference frequency which is used in direct synthesis method. In case of this frequency synthesized generator is 18 megahertz. Okay, it's important. Now this 18 megahertz frequency is used, which is divided, mixed, multiplied to provide 10 outputs. So from this 18 megahertz, we are getting 10 outputs in 100 kilohertz step from 2 to 2.9 megahertz as well as 16 megahertz outputs. So this is the expected value which we can obtain in direct synthesis method from 18 megahertz reference frequency. Okay, so rather than stabilizing the frequency of VCO, VCO is voltage controlled oscillator. By comparing the phase of fraction of this VCO's frequency to the reference frequency, what they are doing, they are having a reference frequency that is 18 megahertz, and we again have the criteria to stabilize the frequency of VCO. So what they do, they actually compare the VCO's frequency to the reference frequency, and this method generates the desired frequency from a reference frequency after the comparison. Okay, so a selected frequency from 2 to 2.9 megahertz set is heterodyne. With heterodyne, I think this word you are much more familiar because in communication system, we actually learn about this term heterodyne. Let's wait for a second. It's not showing. Okay, so this set is heterodyne with. So what is heterodyne? Can you tell me? Explain the term heterodyne. Can you explain the term heterodyne? Anyone? Any idea? What is heterodyne? Respond. What is heterodyne? Have you heard of this word before, Aditya?
No idea.
No idea? Okay. So you don't know about heterodyne. So let me explain about heterodyne first. Yes, yes. What? Yes, Aditya?
I think heterodyne is a type of multiplexer which
Yes, yes.
can multiplex.
Yes, very good. Correct. He is absolutely correct. It's a actually heterodyne is a signal frequency. Okay, or you can say how it is created. It is created by combining or mixing other two frequencies. So, if in short you want to say that what kind of thing is that, very simple. It's a multiplexer like this. So you can draw a multiplexer like this. So this has to be an ideal mixer or ideal multiplexer, whatever. You can write it's a multiplexer. Multiplexer, and you will give us input signal. There will be an input signal. Okay, and here will be an output signal. Okay, so this is the thing. And actually here what happened, the combination of many frequencies come here, and here will be a local oscillator. Okay, just like this. So heterodyne, if you ask that the total process of heterodyne, if you say that's a long process, so I can show it for you. Let me share my whiteboard. If you say, heterodyne, if you say, then what are the components in heterodyne? First of all, in heterodyne, it comes RF filter. Okay, it comes RF filter. Okay, RF filter it comes. So the symbol is somehow like this. Okay, RF filter. Then it comes RF amplifier. This is like this. RF amplifier. Okay, then it comes a mixer like this. A mixer comes. Then it comes something IF amplifier and filter. Filter you can say. Okay, filter. Then comes a demodulator. Okay, we know this coming. Demodulator. Then it comes audio amplifier. And then to the destination source, whatever. And here a local oscillator will be connected. So this is the actual structure of a heterodyne, if you say. Okay. So let me move to my PPT. So you see here what's written. A selected frequency from 2 to 2.9 megahertz is heterodyne with 18 megahertz reference frequency, and the sum is filtered to produce 10 selectable frequencies, that is ranging from 20 to 20.9 megahertz in 100 kilohertz steps. Okay, so this is the thing or the process how we can heterodyne or with our reference frequency, that is 18 megahertz, and the sum is filtered like this. Okay. So now we can move to the next slide, that is block diagram of the Dirac synthesis. See, it's a bit complicated diagram because many functions are going on simultaneously. So if you check it out, this diagram properly, if you see here, see, in everything you can see one more thing very clearly. The source is 18 megahertz, right? It's a reference frequency. Okay, so and this is my 20.0 20.9 megahertz. This is one frequency, then 16 megahertz. So many things are combined here, and it has been showed the decoding everything. Okay, and what are the components have used. The multiplexer has been used. Okay, so every time you see there's a change in frequency, not the reference frequency, but inside the device, the frequency changing is going on. That may be VCO frequency or anything. Comparison is going on. So this is the example of a Dirac synthesis picture. Now we can move to the next slide. Some descriptions are written here. Just have a look. This frequency is divided by 10 mixed with 16 megahertz and so on. So this is the actual process. Whatever you are seeing in the diagram, just now the diagram I showed you, that here what is happening, the frequency is divided by 10 and then mixed with 16 megahertz and so on. So it can be seen from block diagram that circuit is repeated for each switch, and repeated circuit are required wherever decade is added. Okay, you can see here decade word is, you can see where is the decade. This is the decade part. Okay, and see the 16 megahertz, where it is taken. Okay, and 10 sections, 10 frequencies, selected frequency they have taken. So every time you can see here. So it's clearly written that every time when decade is added, repeated circuit is required. Okay. Now, although synthesizer circuits appear complex and expensive, each decade is identical with previous decade. So if you just compare one decade with another decade, you can see that each decade is identical because there are no frequency circuits. So frequency here can be changed instantaneously in addition of each decade, because the entire operation that is going here from a single frequency source and close in spectrum, there can be that is an undesired modulation is going on. Okay, without any undesired modulation. So modulation is happening here, but that is somehow desired. When the frequencies are changing from 18 megahertz, then this frequency divided by 10, then it's mixing with the 16 megahertz, modulation is repeating. Okay, there is no undesired modulation, so everything is going on accordingly, and the frequencies change practically instantaneously in addition of each decade. So you can see from the above picture that what are the decades added here. You can see now what are the decades added here. So there are some applications of this frequency synthesizer, signal generator, that is radio receivers, mobile phone, radio telephone, walkie-talkie, satellite receivers, GPS systems. So in all these devices, you can find the application of this particular device. Okay, so frequency synthesizer can combine frequency multiplication, frequency division, and frequency mixing. So here they have again written what is mixing. It's a process that generates a sum and difference frequencies operations to produce the desired output signal. Okay, so this is the thing. This is the about everything about frequency synthesizer. Okay, so we can now move to the next topic of this chapter. Let me see. Our next topic is frequency divider generator. Wait, this. After frequency synthesizer, we have the next topic, frequency. If you check out your syllabus, if you are having frequency who is there? Hello.
That complex diagram.
Rajkumar, your voice is not audible, not clear. I'm not getting you. थोड़ा ठीक से बोलो. हाँ, कुछ सुनाई नहीं दे रहा है.
मैम वो डायग्राम जो था कॉम्प्लेक्स डायग्राम वो एक ही डायरेक्ट सिंथेसाइजर है.
हाँ, एक ही है पर उसमें अलग अलग डिकेड लगा हुआ है. लेट मी शो यू. वेट, एक मिनट रुको, मैं एक बार दिखा देती हूँ. देखो, डायग्राम इज जस्ट फॉर अंडरस्टैंडिंग. आई वोंट से कि एग्जाम के टाइम डायग्राम जरूरी नहीं है. इज जस्ट फॉर अंडरस्टैंडिंग पर्पस. एक ही डायग्राम है, ठीक है, बस डिकेड अलग अलग है क्योंकि यहाँ पे फ्रीक्वेंसी चेंजिंग हो रहा है ना. एवरी ईच एंड एवरी स्टेप फ्रीक्वेंसी इज चेंजिंग. यू कैन सी हियर द डिकेड्स. देयर आर 3 डिकेड्स. जो मुझे दिख रहा है इस पिक्चर में 3 डिकेड है यहाँ पे. सो इन एवरी डिकेड frequency is changing, but you see the source frequency is constant, that is 18 megahertz, है ना. So after that what is happening, it is dividing by 10. You can see here, देखो यहाँ पे picture में show भी हुआ है that how it is getting divided by 10. फिर they are mixing with 16 megahertz frequency and then so on. Okay, it's a single diagram, but there are 3 decades. Okay, 3 decades are there. So each and every addition of decades what make it easier कि हमें और भी ज्यादा amplified signal we can get. Okay, modulated signal, more amplified signal we can get. That is why they have used 3 decades in this case of frequency synthesizer. Okay, now is come to the frequency divider generator. कुछ ज्यादा कुछ नहीं है. So let me just have an overall idea about it. Wait, let me give you the basic idea. Stop sharing. Okay, this is my heterodyne. Go to the next page. So my topic is frequency generator divider, something like that. What is this? See, frequency generator, generator circuit which generates frequency definitely, and divider circuit definitely. What it will do, it divides the generated frequency with various factors to get different frequency value. So see here, अभी मैंने जो picture I have showed you, वहाँ मैंने क्या बताया कि मेरा जो 18 megahertz जो frequency है, that is my source frequency. It is then divided by 10. Okay, so this यहाँ पे जो ये process है कि मेरा जो reference frequency है, that is I am dividing by 10. So here comes the use of the divider circuit. Okay, so divider circuit, what is the function of divider circuit? It divides the generated frequency with various factors to get different frequency values. So various assembled frequency generator and divided circuit are available in market. You can see, but you know they are quite expensive also, because see, whatever device we use in our laboratory for our experiment, that can't be so much expensive, right? It has to be somehow commercial. So the frequency of 1 hertz, 10 hertz, 100 megahertz, 1 kilohertz, 100 kilohertz, or 1 megahertz, they are obtained at the output according to the source frequency we are using. So output pulse here are selected. I mean, if you check out any divider circuit, you will find many switches are connected. It's a very complex, I mean, frequency divider circuit, if you see using any counter, any decade counter, it's a very complex circuit. So I will not go into detail of such a complex thing. So just have a basic idea that this frequency divider circuit has a direct connection with the frequency synthesizer signal generator. तो वहां पे उसका जो भी प्रोसेस हो रहा है फ्रीक्वेंसी सिग्नल सिंथेसाइजर सिग्नल जनरेटर में, उसका एक पार्ट जो है, जो कि मेरा रेफरेंस फ्रीक्वेंसी जो है वो डिवाइड हो रहा है 10 के साथ, दैट पार्ट यू कैन रेफर एज फ्रीक्वेंसी जनरेटर डिवाइडर. ओके, ये मैं एग्जांपल से समझा रही हूँ कि दिस कॉन्सेप्ट इज देयर. Okay, so nothing more you have to go into that, because otherwise if you enter much detail of this, it's a very complex circuit and it's not even in a book also. So isko yahi tak rehne do, theek hai. So I think you understood what does divider mean. That will help, that will only do. Acha, let me see what is the next topic you have. The next topic is signal generator modulation. Wait. Yes, Rajkumar, tell me.
मैम एक बार फिर से बोलिएगा हेट्रोडाइन.
अच्छा, हेट्रोडाइन.
यस मैम.
ओके, बताती हूँ. हेट्रोडाइन ना, वेट, हेट्रोडाइन व्हाइट बोर्ड में है हेट्रोडाइन का पिक्चर. ओके
मैम उसको यूज क्यों करते हैं
उसमें? रिपीट
मैम, उसको यूज क्यों करते हैं?
अच्छा, why we use heterodyne? We use it. See, there has to be a device na, where we can mix 2-3 frequencies together. तो heterodyne का अभी जो आदित्य ने बोला था कि मैम frequency heterodyne is a mixer or is a multiplexer, okay, where combination and mixing of 2 other frequencies can happen. So heterodyne, you can say it's a signal frequency that is created by combining or mixing 2 other frequencies. Okay, so don't think that heterodyne का मतलब क्या है? See, always we know homogeneous मतलब homogeneous, that means what? Same frequency or same जो भी पैरामीटर है same. हेट्रोजेनियस का मतलब हमेशा क्या होता है? हेट्रोजेनियस से आया है ये वर्ड हेट्रोडाइन. Okay, so heterogeneous का मतलब है different, 2 other, okay, 2 different frequency or 2 different parameters. So from there the thing has come heterodyne. Heterodyne का मतलब ही वही है कि 2 different frequency. So the combination and mixing of 2 different frequencies, actually in that case this heterodyne device has been required. Okay, and this combining and mixing of 2 frequencies इसको बोलते हैं, एक टेक्निक है. क्योंकि it is happening through heterodyne, so it is called heterodyning. Okay, it is called heterodyning, and this was invented by some scientist or something. So new signals which actually come up using this heterodyne or with the process of heterodyning, the new signal which is obtained is called heterodynes. Wait, it is called heterodynes. Okay, so heterodyne principle, if you say, then principle is that multiple frequency applied to a non-linear device producing a new frequency that are sum and differences of the applied frequency and definitely with their harmonies. Okay, so that is the heterodyne. So heterodyne, homodyne भी एक चीज है, but homodyne is not required here. So heterodyne come from heterogeneous. Okay, something super heterodyne is also there in communication system. I don't know whether you have learned or not. So this heterodyne, everything super heterodyne, Everything come from the come from communication system or analog communication, digital communication. So if you're learning that, definitely you will get to learn these terms. Okay. Okay. So next we will move on to signal generators. Signal generator is important topic of this chapter. चलो उस पे move होते हैं. Actually in our syllabus, our next topic is signal generator. So from there, signal generator modulation we will go through. I think my whiteboard is visible. Okay, so I'm writing here signal generator. Okay, so now signal generator, what is that? Basically, it's a source of sine wave. There are some points. Okay, signal generator, it's a source of sine wave voltage. It's a source of sine wave voltage with an appreciable range of frequency. Okay, and amplitude, both of which are known as, you can say, high degree of accuracy. Now the question comes, why we use signal generator? There is definitely a standard signal generator. So this kind of instrument actually is provided with means of modulating the carrier frequency, which is indicated by differentiating. Now modulation is indicated by a meter. So modulation may be done by a sine wave, by a square wave, by a triangular wave, or by a pulse. So modulation, you have the idea. I hope. Idea of modulation you have, because you have gone through analog communication, everything. So modulation may be done by sine wave, a square wave, triangular wave, or a pulse. So output signal may be amplitude modulated or a frequency modulated. Okay. So usually amplitude modulation is mainly employed in case of standard signal generator. So I'm showing you a simple signal generator picture. So just have a look. What you will be having, first of all, you will be having a RF oscillator. RF oscillator. Okay. Then here amplifier. Okay. Then output attenuator. Okay. Then output meter will be there. Okay. And then you will get the output. I'm writing O by P. And here modulation oscillator will be connected to the amplifier here. So you can write here modulation oscillator. Okay. And here something range of frequency will be there because it's oscillator. Okay. And here in the modulation oscillator, what are the things you have to keep? That is, one is definitely modulation frequency. And another is percentage of modulation. Okay. So this is the basic block diagram. Basic block diagram. A basic block diagram of a standard signal generator. Okay. So this is a basic block diagram of the signal generator. You see here very clearly the carrier frequency sinusoidal that is produced by a that is produced by a very stable RF oscillator. Okay, so the carrier frequency, maybe it's a sinusoidal, that is produced by a very stable RF oscillator using LC tank. LC tank circuit, which I have not shown. LC tank, you can understand inductor capacitor tank. Sometimes they are inserted inbuilt in the RF oscillator. So the frequency of the oscillations here is indicated by various frequency range control. Now amplitude modulation is provided here either by any internal or external frequency oscillator. Now modulation is done in the output amplifier circuit. See, amplifier circuit has been connected here, and this is the attenuator, double T. So and this amplifier delivers its output to an attenuator. So whatever output you are getting from the amplifier, that is definitely is a modulated carrier. Okay, whatever output you are getting, that is a modulated carrier. So it's some communication part is coming here, so you could understand. So modulated carrier, and that is becoming the input of this attenuator. Okay, so this amplifier delivers its output to an attenuator. The output voltage is read by an output meter and then the attenuator output setting. So you can see output meter is connected here. So modern laboratory type signal generators incorporate certain features. If you see in any modulation, in any communication lab, this kind of signal generator, many updated signal generators may also there. Okay, but this is the basic thing, that RF oscillator, amplifier, attenuator. So these three are the main components, that how the signal generator is producing the output. Now the frequency stability of the oscillator must be high at all frequency ranges. Okay, and the frequency stability actually depends upon you can say on the constant supply of the voltages, and therefore regulated power supplies are used. Because definitely when you are converting, when you're getting a carrier frequency which is given to the RF oscillator, that definitely should have a constant supply and the regulated power supply. So in order to maintain the stability, the temperature compensation devices also should be used in this kind of generator. So in high frequency oscillator, it is very much essential to isolate the oscillator circuit from the output circuit. So isolation is necessary. Why? In order that the changes which occur in the output circuit that do not affect the oscillator frequency, their amplitude, as well as the distortion characteristics. So sometimes what happens, buffer amplifiers may also be employed for this purpose. Okay, so that thing we can see in some other type of advanced picture of standard signal generator, which I'll show you in the next class, because that I can't draw, that I have to show you through the PPT. That's another type of standard signal generator. You can say basically laboratory type signal generator. So master oscillator, you can see, has been used there optimally to designing for the high frequency range. See why we use this kind of signal generator. What is our motto? That thing you have to understand our motto, so that we can get much amplified signal, modulated signal, but at a very high frequency. So what picture I'll show you for this particular standard signal generator in the next class, that will be a basic diagram for the laboratory type signal generator. Okay, and you can see here some extra components apart from this. RF oscillator will be there. That's a very constant component. RF oscillator, amplifier, these are very constant components you can see. Okay, our main thing is that modulation. Modulation is very important, and calibration definitely. So these things are there. So today I can't show you that picture. Yes. Yes.
Ma'am, would you please explain the role of output attenuator?
Okay, output attenuator. See, what is the input of the attenuator? Can you tell me? What is the input of the attenuator?
Modulated carrier signal.
Yes. So first you have to understand what is attenuator. Now, attenuator is a device that reduces the power of a signal without distorting the waveform. That means whatever modulated carrier we are getting from the amplifier, exactly that carrier is being passed through the attenuator so that it's totally maintained. मतलब उसका waveform बिल्कुल भी distorted नहीं होना चाहिए. Okay. If actually what happened, if directly amplifier से हम output meter को connect करते हैं, it may happen that output meter is not so much capable of getting the exact carrier waveform. ठीक है, maybe some distortions are possible. output meter में exactly waveforms आना possible नहीं होता है. That is why we are connecting the attenuator so that this attenuator थोड़ा power को reduce करके waveform को distortion होने से prevent करता है. Then from the attenuator, the waveform is being compressed, and then the actual, that particular, you can say some attenuated waveform, जिसको हम बोलते हैं, when the waveform pass through attenuator, we call it as attenuated waveform. That attenuated waveform is then passed through the output meter. So you can say that as we reduce the power, the whatever the waveform, the design of the waveform, that is called attenuated waveform, that is then passed to the output meter. So this is the work of the attenuator, just to keep intact the modulated carrier waveform. Okay, and then we are passing it to the output meter. हम जब standard picture का मैंने बताया ना, I will also discuss with you another picture of the standard signal generator. There you will also find the function of this output attenuator.